In section 9.6, we're going to be looking at how to solve rational equations. So these are equations where we have variables that we're trying to solve for in the denominators of fractions, like these here. So sometimes they're actually really simple to solve. So for part A, I have a fraction equal to another fraction. Now, although they contain variables, this is actually, we can solve it by using cross multiplication. So here, we can simply cross multiply to solve for x, because we want our final answer to just have x equals something. So when we cross multiply, we have x times 4, that's 4x, equals 3 times, now when you have two terms, like x plus 2, you need to put it in parentheses when you multiply. So 3 times x plus 2. Make sure you put that in parentheses. Now, I've got 4x equals 3x plus 6. Just use the distributive property. Subtract 3x from both sides. I end up with x equals 6. And I have solved. Okay, so that one's not bad. Just using some cross multiplication. Over here, part B, we can use a similar technique. There are different ways to solve these, but the first way I thought of to do this was anything can be put over 1, like x minus 8 over 1. That didn't change the value of x minus 8 at all. So I essentially just made this left side into a fraction so that I could, again, cross multiply. So I'm going to say x minus 8 times x times x minus 8 equals, now this negative's got to go with either the 12 or the x. I'm going to make it go with the 12. So I get negative 12 times 1 is negative 12. And I'm going to distribute x squared minus 8x equals negative 12. Ooh, I see I've got a quadratic here because of the x squared. So let's set it equal to 0. Add 12 to both sides. Now here's where some skills from chapter 6 come in. So I can solve this a variety of different ways. I could use the quadratic formula. I could complete the square, or I could factor. I'm going to choose the factor because I think that's the easiest in this case because it is factorable. So I'm just going to put, just so we know, solve using any method. Any method from chapter 6. I'm going to choose the factor. So if I try to factor this, I want to come up with two numbers that add up to negative 8 and multiply to give me 12. That's negative 6 and negative 2. Now when I go to solve this, I need to set up two equations. Either this factor could be 0 or this one could be 0 to make this true. So I'm going to say x minus 6 equals 0, x minus 2 equals 0. That's going to give me two solutions, x equals 6 and x equals 2. There we go. Okay, so another cross multiplication one. This time we ended up with quadratic. We were still able to solve. Okay, if you flip your paper over, we're now going to solve one that's a bit more complex. Okay, so we don't just have a fraction equal to another fraction. We have some addition going on the left side. So like two fractions with different denominators. So I can't cross multiply with this one. But if you think about if you had a normal, let's say, if you have an equation with fractions, if you multiply everything by the least common denominator of the fractions, that's going to get rid of the fractions in your problem, and you can just solve normally. So that's what we're going to do here. Same thing holds here. So we're going to say, we're going to multiply everything by the least common denominator in order to eliminate fractions. Okay, so I'm going to look at my three denominators. I'm going to do some side work over here. This is to find my least common denominator. I'm going to write down all of my denominators, 28, x plus 2, and 4. Those are my three denominators. Then I'm going to factor them if possible so I can do my circling. So 28, if I were to make a factor tree, that's equal to 2 times 2 times 7. broken down into its prime factors. X plus 2, there's really no way to factor that anymore. 4 I can write as 2 times 2. Okay, so when I do my circling, I'm going to ask myself, okay, which one has the most 2's? Well, these ones both have the same amount, so I'm just going to circle this one. There's a 7 somewhere. This one has a 7. It's the only one that has a 7. And then I have an x plus 2, so that's another one I need to circle. So my least common denominator is going to be all 3 of these multiplied together. So least common denominator is going to be 28, because that's 7 times 2 times 2. That's 28 times x plus 2. Okay, so if I take my equation here and multiply everything by the least common denominator, that's going to eliminate my fractions. So I'm going to take, so it's 28, 28 times x plus 2. And then I'm going to multiply that with, this is the original left side of my equation. Oops, sorry, 28. And then that's equal to, originally I had 3/4, and I'm going to multiply that. Multiply that by my least common denominator as well. 28 times x plus 2. So I just took this, multiplied it on both sides of my equation. And now let's see what happens. So technically, since I have this addition here, I need to distribute this to both of the terms inside the parentheses. So get ready for some writing here. I'm going to distribute to both terms. So I'm going to have 28 times x plus 2 times 9 28ths plus, now distribute to the second term, 28 times x plus 2 times 3 over x plus 2. Okay, I just used my distributive property here. Equals. Now let's do the left, or the right side, sorry. Well, this side, there's really nothing to distribute since there's only one thing here, but maybe I can simplify a bit. So I have 3/4 times 28 times x plus 2. You might notice 4 and 28, those have a common factor of 4. 4 goes into itself once, and 4 goes into 28 7 times. So that'll simplify things a little bit. And then I'm just left with 3 times 7, which is 21 times x plus 2. Okay, and then let's see if we can simplify some things on the left side here. Okay, ooh, 28s cancel out, which is nice. That was the whole point. I wanted to get rid of the fractions. So I'm just left with 9 times x plus 2. And then over here, my x plus 2's cancel out. So I'm left with 28 times 3. Okay, from here it's just a normal equation. So it should be pretty easy from here forward. Distribute, you get 9x plus 18. We're going to pause this for a second.